Okay, this is just a quick video to go through the little mini assessment that you did before half term. So I'm just going to quickly go through most of the questions. There's a couple that I'll focus on a little bit more, but I'm just going to go through it so you can compare it to your own, have a look at what you've got right and wrong, and then obviously use that to inform which target work you do. So question 1 and 2, pretty straightforward, contact and non-contact forces. So a contact force is one where something has to be touching, so something like friction, where if you've got two objects rubbing together, it causes friction. If they're not touching, there is no friction. Whereas a non-contact force is something that does not have to be touching, so in this example that will be weight, and you can see they've ticked if they're correct, so you can just go off this. So weight is gravity pulling you down, and imagine if you jump in the air, you don't fly off into the sky because you're not touching the ground anymore, you get pulled back down even though you're not touching the ground. Okay, number of waves per second, that's just a simple definition, is frequency. And then a couple more simple questions that are just things that we just need to remember basically. Vector and scalar quantities. So a vector quantity, as in which has a magnitude, magnitude being size or amount of something, and a direction. Okay. Whereas a scalar quantity is something which just has a size. So velocity, remember, is speed in a certain direction, and acceleration is change in velocity, so it's going to be the same as velocity basically. So speed's got to be the one that doesn't have a direction. Which of these is not an electromagnetic wave? Question 6, that would be sound. Light and radio are on your electromagnetic spectrum, so think about your electromagnetic spectrum song, like radio waves, microwaves, and so on. Sound is not in there, so it's not. Okay, a free body force diagram. So I'm going to draw one of these on here because that goes into the next question anyway. I want to focus on a little bit more. A free body force diagram is one of the diagrams that we've been using where we might have like a ball, okay, and we have some forces acting on it. So we have an arrow that way and an arrow that way. So the size of the arrow shows how big the force is, but the direction in this one shows the direction that the force is pulling in, so the direction that it's going in. So in terms of asking in which way does an arrow that represents a force point in a free body force diagram, force diagram, it points in the direction that the force is moving in. Okay, number 8. So on number 8, this says that we've got a skydiver with 750 newtons of weight. So if we've got our little skydiver here, okay, jumping out of the plane, they have got 750 newtons pulling them down, and they've got 600 newtons pushing them up of air resistance. It wants to know what the resultant force is. Now the resultant force is the overall force acting on the object. So we take those away because they're opposite. If they were the same direction, we'd have them together, but they're going away from each other. So we do 750, take away 600, and that gives us 150 newtons, and it is going down, because that's the bigger force. Okay, next one. So now we're looking at an equation, and it's the equation linking weight, mass and gravity. So the equation we should be using is weight equals mass times gravity. And if we use this for this next question to calculate the weight of a child, so we don't know the weight, with their mass is 40 kilograms times gravity on Earth is 9.8. You need to remember that gravity on Earth is 9.8. So it's always that if it's on Earth. It's different if you go to a different planet, but it's always 9.8 on Earth. So to work that out, so weight is 40 times 9.8. That should give us 392 newtons of force. Okay. Obviously you need to check, like, if you got 392, I should have marked that right for you. If you got something different, obviously. If you wrote it a different way to what the answer gave you, it might have not marked it right for you in the first place, but I will have corrected that. Okay, how are all electromagnetic waves the same? They all have the same speed. If you remember, all electromagnetic waves travel 300 million meters per second, which is the speed of light. Next one is another formula. So this is the formula that links with Newton's second law, which is force equals mass times acceleration. And again, we're going to use this on this next question. So how much force, we don't know, is needed to make a 24 kilogram object, so that's our mass, accelerate at 3 meters per second. So we're going to do 24 times 3. If we do that, it gives us 72. So our force is 72 newtons. Next question. A resultant force, what happens to the motion? So if there is a resultant force, this is Newton's first law. So Newton's first law says that if there is no resultant force, an object will remain the same motion it's doing already. But if you have a resultant force, so if we've got a force pulling on something, so if we've got an object and we have, say, a big force in this direction and only a little one in this direction, our resultant force is going to go this way. And that's going to make the object accelerate in that direction. So it's going to be the third answer there. Okay, number 15. If an object is moving at a constant speed, which statement is true about the resultant force? So if it's moving at a constant speed, the motion's not changing, so that means they're going to be equal. So this, if you imagine a car driving along a road, okay, if it's got, say, 100 newtons of engine force and 100 newtons of friction, and it's going, let's say, 50 miles per hour, okay, it's going to continue at 50 miles per hour because there's nothing speeding it up and nothing slowing it down. Because the resultant force, they cancel out, 100 take away 100 is 0. Newton's third law, every action has an equal, what word conflicts Newton's third law? For every force acting on an object, there is an equal, and it should say opposite force there. So if you ignore what it says for the correct answer there, if you've got that one and you put opposite, I would have corrected that for you, hopefully. Number 17, 2 words complete Newton's first law. An object will continue with the same velocity or remain stationary if there is no resultant force. I've already mentioned that one. Right. What word describes an object that will return to its original shape once forces are removed? That is an elastic object. So it's elastic if it will go back to its original shape, and it's plastic if it won't go back to its original shape. And this next one we're going to use another equation. So this time, I'm using the equation force equals spring constant K times E for extension. So this time we know the force is 20 newtons. So it says that the spring extends elastically by 10 meters when the force is 20 newtons. Is applied to it. What force will be needed to extend the spring by 5 meters? Include the units for your answer. Okay. So there's a couple of ways of working this out actually. We could do it using the equation, but a simpler way of doing it is looking at the equation and thinking, right, so basically what am I doing? My extension is times 2. It's the same spring, so this number is the same. So we've got to think about what happens to the force. So if we double the extension and this spring constant is kept the same, that means we're going to need double the force. Okay? So we started with, sorry, not double the force, half the force. I'm going the wrong way around there. We've got half the extension, so we need half the force. If we double the extension, we need double the force. Same thing. Basically, whatever you do to the extension, you do the same to the force. So in this case, half in the extension, half in the force. So it's going to be 10 newtons. Right, moving on to this next set of questions. This is where I want to focus a little bit on these because we're getting these wrong still. So we've already said about the car. If it's got the same force forwards and backwards, the important thing is it is being driven along a straight road. It's already moving. Okay, so if it's already moving, it's going to stay at a constant speed. It will keep going. It won't stop. It won't stay still because it's not still. It will maintain a constant velocity or constant speed. In B, because it's got a bigger force forward, it's going to speed up or get faster or accelerate. And C, it's got a bigger force backwards, so it's going to get slower. So basically, if the forces are the same and it's already moving, it will keep going at the same speed. But if it was stationary, then it would stay stationary. But if you've got a bigger force forwards, it will accelerate, and a bigger force backwards will make it decelerate. Okay, number 23. So this is the first one where we've got to do a bit of extended writing on this one. So we've got an object in a bucket of water, so something like this. And it says that a student says that it's not moving, there can't be any forces on it, and you've got to explain if that's true or not. And you should have said first off it is false. So you want to think about first, this is false. And you're going to get marks for saying why that's false in terms of the forces acting on it. So the first thing you can say is that it's false because there is a weight or gravity force pulling it down. And there is also something pushing it up as well. Because if it was just weight, then it would fall to the bottom, but it doesn't. So there's going to be some sort of uplift or buoyancy keeping it up as well. So if you mentioned weight, you got 1 mark, and uplift for your second mark for that one. Okay, number 24 was worth 6 marks. I'm not going to write the whole thing out for you here, so it'll take me all day. But you want to think about braking distance and thinking distance and what they are. So basically, if you're driving along in your car, I'm going to draw another car here. Should have just kept the same one up from before. So we're driving along in your car, okay, and you see something jump out in the road. So a person jumps out in the road, for example. So if you're sat in your car, you're going to see them at some point, and it's going to take you a second to think about it. And in that time you think about it, you're going to have your thinking distance. So that is the distance travelled in the time it takes you to react, or the distance travelled between seeing something in the road and pressing the brakes. And you're also then going to have your braking distance, and hopefully that's not going to let you hit the person. And that is the distance you travel under the braking force, or the distance you travel between pressing the brakes and coming to a full stop. So you want to explain what those things are, and then think about what can affect them. So things that can affect your thinking distance are things like alcohol, distractions, things like that. Things that affect a person, and things that affect your braking distance are more about things that affect the car. So things like the weather, if it's icy or wet, things like the state of your tyres or your brakes, things like that, are going to affect how far you go under braking. Also, speed is going to affect both of those, your thinking and your braking distance. Okay, so your speed is going to affect your thinking distance, and it's going to affect your braking distance. Right. I'm going to leave that there because I've not given any of the other ones as targets that are later on than this question, because I want to focus mostly on these forces because I think that's where we struggled the most. It's the ones we've done, but it's been the longest time since we've done those ones, and so therefore it's going to be the ones that you've not done for the longest time. But I will just quickly scroll through the rest of them just to show the answer so you can see what they should have been if you want to. So I'll just scroll through, and you can pause it as you need to see the rest of the answers. And if there's a couple that you need to put in, I will go through them quickly. So 28, you should have said it's an anomaly. 29, if you look at the numbers, the higher the drop, the higher the height. 30, it will never roll up because some, energy will be lost, so friction will slow it down. 31, it's a permanent magnet. 32 should be bar 2. And 33, I'm not going to go through much, but not a bad job. But basically, you just need to pick 3 points and just make 3 points. So maybe you could have said A started off faster, okay, covering more distance at the start, and giving you an example. So say at 40 seconds it was at 300, whereas B was at 150 maybe, and then you'd say, but they at this many seconds here, so what's that, 110, 115 seconds, B overtook A, something like that. So you're just making 3 points and backing it up with evidence to get you 6 points in total there. Right, so that should be it. So I want you to go through now and do all of the target work that you need to do. You should be able to work out what that is. Any problems though, obviously ask me and I will help you with